Welcome to our first lecture on waves in optics. These notes can be found in your Dropbox file, http://db.tt/lowercase l 36 capital E 1 P3 small o. That's not a zero, that's an O. Okay, our first equation in this lecture is V is equal to lambda times F, where V is the velocity. Oh, we've seen that before. This is the Greek letter lambda, means wavelength, and the F is frequency. Meters per second, meter, okay. Really the only new wavelength, okay, there's our meters. Frequency is per second, something per second, cycles per second, or hertz. You might see this as V is equal to lambda nu, okay. I think they're getting away from this because a lot of people claim that's another V. But this is the Greek letter nu, which it looks like a V kind of tilted over towards the right. You're probably thinking how to write the lambda. The easiest way, you see what I did, I just, for lambda, just draw a line like this, about 45 degrees, and about halfway up, just do like this. Okay, almost looks like a backwards Y, backwards offshoot Y. But be very careful on that. Okay, so let's look at the first one. Okay, it says, so we have a frequency and a wavelength. Oh, golly, I know I got to use this one, because lambda F. You're thinking, ooh, how fast am I going? Because the only thing I have is that. Okay, and I'm looking for lambda. Sometimes look get crazy on that, and that's in meters. Okay, remember, it's a light wave. Okay, any light wave, electromagnetic wave, and let's put this here, that the V is equal to the speed of light, 10 times the 8th meters per second. So there it is right there. So if you're not going to calculate the speed, or you see it's a light or electromagnetic wave, everything's going pretty fast, 3 times 10 to the 8th meters per second. And there it is. Okay, wave. Okay, I didn't tell you what type of wave it is, so we're going to assume that it is some type of a EM wave. That's a short for electromagnetic. Equals wavelength times the frequency. You know, it's just right here, like that. There it is. Okay, since I did not give you the velocity, use 3 to the 8th. That's 3 times 10 to the 8th. We've got a wavelength. Well, would help if I read. It's 2 times 10 to the minus 10 times frequency, and frequency is in hertz. Okay, so make sure it's nice and clear. F's a lowercase f, not a big case F, which would call it a force. No, this is a lowercase f. Here's one with sound. Okay, now with sound, I gave you the speed or velocity. Okay, so it's at 343. And it says the wavelength and the frequency is 440 hertz. Okay. Not bad, was it? Here's another one. Radio station frequency. Okay, I did not give you the V, so we know radio waves are zipping along at this 3 times 10 to the 8th. Okay. That's 3 times 10 to the 8th. Okay, the wavelength. Now the frequency, remember that has to be in hertz, so you got to know that says mega 101.3 times 10 to, okay, mega is 6, and there it is. Real simple, wasn't it? Okay, that's pretty much it on this. I mean, it's almost like solving for a kinematics problem we did way back when. But remember that the V has to be in meters per second. There we go, meters per second. The lambda is in meters, frequency is in hertz. You might see the new, so be very careful about writing this and also writing your lambda. Teacher will probably take off for it if you don't write it clearly, so be very careful on that.